Hello and welcome to my video. This is the third and last video of my elementary function week series. So if you haven't watched my previous two videos, please check those by clicking the link on top right corner. In this video, we are going to solve the following problem. So the function f from real number to real numbers is defined like this. So fx equals minus x when x is positive or 0, and fx equals x squared when x is negative. So the graph of fx actually looks like this. Now, define function gx as f(f)(x). So we have a function composition here. Then find the inverse of gx. Here, this minus 1 means inverse. Right, so we have to find the inverse of a function. Okay, so first we have to find the gx, which is f of fx. It looks a bit tricky at first sight because fx is defined differently in two different regions. But let's just stay calm and recall the very definition of the function composition. So we can write f of fx as we simply replace x with fx. So we have minus fx here when fx is positive or 0, and we have fx squared here when fx is negative. Now what we have to be careful are these new domains. So here we first have to determine the range of x that makes fx either positive or negative. And by our definition of fx here, fx being positive or 0 is basically equivalent to x is negative or 0, because from here fx is positive when x is negative and fx equals 0 when x equals 0. Similarly, fx is negative if and only if x is positive. Again, from this definition and from this graph, it is fairly obvious. Therefore, we can say like this. First, consider a case where x is positive. Under this condition, the expression for fx is minus x, and this fx is also negative, which is this condition. So therefore, we have to use this. So gx equals fx squared, and since fx is minus x, we have minus x squared, which is x squared. Okay, secondly, when x is negative, then we have an expression fx equals x squared now, and this value of fx is positive. So here, since we are now under this condition, we have to use this. So gx is equal to minus fx, which is minus x squared. And lastly, let's consider when x equals 0. Let's investigate this case separately. Then g0 is simply f(f)(0), and since f0 is 0, we have f0, which is 0. And for this 0, you can see that both expressions gives value 0 when x is 0. Therefore, we can write gx like this. Gx is x squared when x is positive or 0, and minus x squared when x is negative. And this equality sign can be anywhere. So this is gx, and the graph of y equals gx looks like this. Alright, so we have obtained the gx. Next, we find the inverse of gx using this gx we have just obtained. When doing so, we must be careful of the domain and the range, just like the previous step. So let us draw the graph of gx here again, because we are going to need it. So first, let's consider this case. Here, gx equals x squared, so we can write the original function as y equals x squared, where x is positive or 0, and y is positive or 0. In order to find the inverse of the function, we must switch x and y. So the inverse is x equals y squared, and here the original range of x now becomes the range of y, and the original range of y now becomes the range of x in the inverse. So we have these ranges for the inverse. Now we take the square root, but we only choose the sign that gives non-negative y values. Therefore, we have y equals square root of x, and the domain is x is equal to or greater than 0. Also, it is definitely worthy to remember that the function and its inverse is symmetric with respect to y equals x. Therefore, from the graph of gx, the inverse is flipping this part over y equals x. So you can see that the range of y of the inverse must be non-negative. Alright, now when x is negative, here the original function is y equals minus x squared, and you can see that both x and y are negative. Switching x and y gives x equals minus y squared, and x and y are both negative, so we have y squared equals minus x. So now we take the square root, but choose the sign that gives negative y values. So we have y equals minus square root of minus x, where x is negative. Again, thinking about obtaining the inverse as flipping over the function over y equals x makes things clear. Since we are now flipping this part, it is obvious that y must be negative in this part. Also, it totally makes sense that we have minus x inside the square root here. In order for the radical function to be defined, the inside of the radical sign must be non-negative. But since we are now dealing with the domain where x is negative, it makes minus x positive. Hence, the function y equals minus square root of minus x can be defined. To summarize, the inverse of gx is square root of x when x is positive or 0, and minus square root of minus x when x is negative. So this concludes this week's elementary function video series. I don't want to stay on one topic much longer, so next week I am going to tackle new topic other than the functions, and I am actually quite excited to do that. So if you found this video useful, please hit like and subscribe to get notified by many more incoming videos, and I will see you in next week's videos.